Friends, today we are going to discuss a very important topic, that is classification of palm as per API 610. You know, API 610 is a standard available for different parameters and different points, different description has been given in this standard, and we are following this standard for manufacturing of pumps. So as per this standard, a pump can be classified into mainly on three different ways. That is, one is overhang type, another is between bearing types, and another one is vertically suspended type. What is overhang type? Overhang type is a pump where you see it is supported by one end of the casing, that is the bearing housing. Here one radial as well as one angular bearing will be there, and the angular bearing it will take axial as well as radial load. So as per this classification, overhang type, there are two types of pump, that is OH1 and OH2. They are horizontal, and the rest of the other four types are vertical vertical overhang. Here you see it is the foot mounted, and here it is the centrally mounted, means your support is provided at the center of the pump casing. Here is the bottom of the pump casing. Here another support was provided, the bearing housing. We'll discuss one by one when I'll discuss this individual types. Then the between bearing types means the shaft is resting on the between bearing. Here is the bearing, here is the bearing. So impeller is resting, shaft is resting between the bearing, and this is the axially split casing, and foot mounted. Here also it is centrally mounted, axially split. Here it is also axially split, between bearings, multiple stages. Here is radially split. Here it is also radially split. And here it is vertically suspended. You see, this is it is BS1, BS2, BS3, BS4, BS5, BS6, and BS7. So BS7. So these are the major classifications of the pumps which we are available in the market, and based on this we are classified it. Next is this is the pictorial form, this is the tabular form. You see it is the overhang type, that is 6 types are there. Here you see the horizontal one, there are two, OH1 and OH2, that is OH1 and OH2. OH1 is center foot supported, OH2 is central line supported, and then OH3 is vertical inline bearing brackets, and then rigid coupling is BH4, and then high speed one is, and vertical inline is only it is also close coupled, it is vertical inline, that is VH5, and another one is gear, high speed, that is integral gear type, that is OH6. Similarly, centrifugal pumps also between bearings also axially split. These are mainly 1 and 2 type. 1 and 2 test, axially split, foot mounted, axially split, centrally mounted, BB1, BB1B, and radially split there is one BB2. And similarly, multi-stage is axially split, is BB3, and radial type is single casing and double casing, BB4 and BB5. And then vertically suspended single casing, that is through discharge column, that is VS1, VS2, and VS3, and then separate discharge pipes, that is line shaft and cantilever shaft, that is VS4 and VS5, and double casing, that is VS6 and VS7. We'll discuss one by one. That is, first one is OH1. You see it is overhang type. Impeller is mounted only on the end of the shaft. There is only one bearing housing, that is cantilever, that's why it is called cantilever. It is radial and angular ball bearing is there to take both radial and axial thrust, hydraulic thrust. It is foot mounted. As it is a foot mounted, so suppose pump is handling an high temperature fluid, then this is going to expand, and how much expansion will take place? Now L2 minus L1 is equal to L1 alpha delta T. Delta is a temperature difference. So this much correction you need to do in your alignment. When this much expansion will take place. Here are another one supports are there to hold the bearing housing. Here it is centrally supported. You will see it is foot supported, foot at the bottom of the casing. here the middle of the casing. So expansion, you see, middle of the, you see that it is the palm picture showing the central supported, you see centrally supported. Here you see it is the bottom supported to each one. So here if it is expansion will take place, so both upward and downward expansion, sidewise also expansion take place. So rotor center line will not change, so there is no need of any correction. And here is also the support provided in the bearing housing is not required. Now OH3 we have told you that is vertically suspended. You see this is the vertically suspended bearing housing integral with vertically suspended bearing. They have a bearing housing integral with the palm to absorb all palm loads. Here it is bearing housing is there. You see here it is bearing housing is there, and it is a flexible coupling. From the here above it the motor will come, so there will be a flexible coupling plus bearing support. This palm will be given a bearing support here, bearing support here. This is called and vertical inline pump means it is a single shaft, and here impeller will be mounted, and the shaft will be resting here by this bearings, radial and thrust bearing are there, and flexible coupling. And here it is, you see it is OH2. I have already discussed OH4. OH4 is rigid coupling. You see it is a rigid coupling, and line shaft. Rigid coupling, one shaft you can say it is rigid coupling. There is here it is flexible coupling. Here it is rigid coupling. So coupling will be there, but it will be rigid. You can say it is a single shaft. It is a rigid coupling. You see it is a rigid coupling. It is called a single shaft. That's why line shaft. Line shaft. Then OH5. OH5 you see it is called close coupling. Close coupling means the motor having a shaft, extended shaft, there is no coupling, so there impeller will be fitted. Impeller will be fitted. That's why it is called closed coupling. It is a closed coupling. The one shaft, impeller, motor shaft having extended portion, there impeller will be there. That's why it is called closed coupling. And here it is high speed. When there will be a gearbox. You see there will be a gearbox. You see there will be a gearbox. So from gearbox shaft, output shaft, the impeller will be mounted, and outputs and pump motor there will be a flexible coupling. So with this it is high speed, and with the gearbox is there, so you can increase the speed, and from the output of the gear shaft impeller will be mounted, and the input of the gear shaft and output of the motor shaft, there will be a flexible coupling. So this is all about the cantilever type pumps. Now between bearing pumps. Between bearing pumps again it is axially split. What is called axially split? If you can remove the top casing axially, axial of the shaft, axially. That's why it is called axially split. Between bearing. Here is a bearing, here is a bearing. So shaft will be mounted between the bearing. Here it is foot mounted, so it will be expansion will be there. So L2 minus L1 is equal to L1 alpha T. So here also temperature correction is required. But here it is the same between bearing, but centrally mounted. You see it is centrally mounted. Though no need of any correction, because expansion will take place both this side, this side, this side, and this side. But rotor center line will remain same. BB2 it is also axially split, but here it is radially split. You cannot axially split it. You radial, when one side from radially you have to taking out the shaft. It is also between bearing shaft. Here it is axially split, multi-stage. There are so many stages are there, and centrally supported multi-stage high pressure requirement. We are using this type of casing. Axially split, between bearing, centrally supported, multiple stages, and axially split. And here it is multiple stages, foot mounted, and multiple stages, and radially split. You cannot axial split is not there, only radial split, and it is single casing. Single is 1/1 casing, single casing. Then next is the pictorial picture. You see it is a foot mounted. with the shaft is feed mounted, here correction is required, L2 is L1 is equal to L1 alpha delta t, foot mounted, here is a foot mounted, so this much expansion will take place. Here it is centrally mounted, you see this is centrally mounted, so there is no correction is required, no correction is required. Between bearing, here is also between bearing, here is also a between bearing, it is radially split, BB2 is radially split, axial split is not there between bearing, but you have to take out the impeller radially, and this is the multi-stage axial split which is multiple axial split between bearing BB3 high pressure application. Here it is also BB4, it is radially split single casing, multiple casing but single not double casing, and between bearing it is also used for high pressure. High pressure, it is also used for high pressure, it is axially split, here it is radially split, and now it is the most sophisticated, most high pressure between bearing pumps, double casing. Here you see the inner, it is inside, it will be looking like this, inside it will be looking like this, one impeller and diffuser, one by one, this impeller and diffuser, this impeller and diffuser, this impeller and diffuser, one by stage, first impeller, then diffuser, then again impeller and diffuser, then again impeller and diffuser, like this. We have to, and outside there is also a casing. Outside there will be a casing. This is for high pressure application, boiler feed water pump. This is centrally mounted. We are using it for boiler feed water pump application. Heavy duty, and then vertically suspended. You see, this is the vertically suspended VS1. Here it is, here is diffuser type. Here it is pass through the it is vertical pass through the column, outside suction, and then pass through the column and then discharge through the columns. This to the column, but it is a diffuser type. It is diffuser. Impeller, then diffuser, impeller, then diffuser. It is impeller. You see, this is impeller, then diffuser, impeller, then diffuser, impeller, then diffuser, like this, and finally it is going out and through the casing itself, column pipe itself. But here it is diffuser type. Here there is no volute type. Here it is, that is VS2. Here VS1 is diffuser type, VS2 is volute type. You see, it is a volute, this is the volute, this is a suction strainer, volute, and then again it is also discharge will be passing through the column itself. Now it is a axial split. It is a axial flow. When you see the impeller, there is no radial flow is not there. From here suction will take place, and it will go axially outside. So this is called axially flow pump. For high capacity, low pressure, we are using this type of pump. It is also passing through the column, pass outside suction, and then the impeller, and it will axial impeller, popular impeller, axial impeller, and then through this column it will go to outside. This is the impeller size. You see, this is not radial, this is not radial, this is not mixed, this is only axial. So VS1, VS2, VS3 difference is there. VS1 is diffuser type, VS2 is volute type. All are passed through the column. Here it is also a single casing discharge through column. Here it is propeller type, mixed axial flow. You see, axial flow. Here is already, here it is radial flow, volute type. Here it is radial or mixed flow. Then it is discharge will pass through the column, Here also discharge will pass through the column. It is high head, moderate flow. It is moderate flow, moderate head and moderate flow. High head, moderate flow. Either high flow, low pressure. That is axial type flow or propeller type impeller. You see, this is till now suspended type of pump. We have all the flow passes through the column itself. Passes through the suction, then passes through the column itself, but not here. It is not passes through the column, it is outside the column. This is VS4, this is VS4. Here it is multiple shaft, and here it is single shaft. Difference is only VS4 and VS5. It is not passing through this main column. There is a separate column is there. You see, after diffuser there is a separate column is there. From here the discharge will take place, but here it is too many shaft. Here it is only line shaft. This is the main difference between VS4 and VS5. You see, VS4, there is too many couplings are there. This is another shaft. This is coupled with the second shaft. This is coupled with the third shaft. This is coupled with the impeller shaft. So all this shaft, this one is VS4 configuration. This is the VS4 configuration. This is the VS5 configuration. Here only line shaft from the after coupling, only one shaft where impeller will be fitted. But here it is, you see, multiple shaft. But it is also line shaft, but multiple shaft. Coupling is there. Coupling is there. So this is coupling is there. So this is the difference. And now this is VS6 and VS7. Here earlier you have seen that there was outside suction was there, and then through the column pipe or through the different column pipes it will pass through. But here you can see double casing. Double casing means outside is also there is a casing. Fluids will come through this and it will go to this column barrel outside, and then inside the pump column it will go outside. So fluid will come to the outer casing, then through inner casing it will go outside. Here it is also diffuser type, here it is also volute type. Here you see it is volute type. It has water is coming to outer casing, then through inner casing it is going out, but here it is volute type, here it is diffuser type. This is the only difference between VS4 and VS7. But both the cases, outer casing is there, only difference is here it is diffuser type, here it is volute type. Here it is diffuser type, here it is volute type. Okay, so I think I have completed all the slides of different classifications of pump as per API 610. So if you have any doubt, if you go through these slides, your concept will be clear, because everything was described here with picture and different points. So if you have any doubt, if your doubt has not clear, then you can talk to me. You can talk to my email also. The questions in interview may ask how many type of pumps are available as per API classification 600 at API 610. Then you can reply it is the cantilever type or between bearing type or suspended or vertically suspended type. What is the advantage of double casing of BB4 type? And BB4 pipe is totally safe. There is no high pressure application, high capacity application. We are using BB4. And boiler feed water pump like this question may be asked and you can answer it, no problem. Or if you are satisfied, I think with these slides you can refer it to your friends and others, colleagues, so it will be helpful to them also.